Assalamu alaikum. I am Khush Mahmood Akhtar Mumu, role BK82250366F. Today my presentation topic is Muntz szasz theorem, variant of stone, weierstrass theorem for polynomials if some coefficients have to be zero. Here are my topic list. So first I like to tell you that here he is Carl Dieter William Ursson, a German mathematician often called as the father of modern analysis, and he is Marshall Harvey Stone, an American mathematician who contributed to real analysis, function analysis, topology, and the study of Boolean algebras. In mathematical analysis, the Western approximation. What is Weierstrass theorem? So, in mathematical analysis, the Weierstrass approximation theorem states that every continuous function defined on a closest interval (AV) can be uniform approximated as closely as desired by a polynomial function, because polynomials are among the simplest functions and because computers can directly evaluate polynomials. This theorem has both practical and theoretical relevance, especially in polynomial interpolation. The original version of this result has established by Carl Weierstrass in 1885 using the Weierstrass transform. Marshall H. Stone considerably generalized the theorem and simplified the proof. His result is known as the Stone-Weierstrass theorem. The Stone-Weierstrass theorem generalized the Weierstrass approximation theorem in two directions. Instead of the real interval AV and arbitrary compact Haustor of space X is considered, and instead of the algebra of polynomial function, a variety of the other families of continuous function on X are shown to suffice as is details below. Here is the Stone-Weierstrass theorem. Here you can see that if f is a continuous complex function on AV, there exists a sequence of polynomial Pn such as a line Pnx equal to fx. Uniformly on AB, if f is real, then Pn may be taken real. This is the form in which the theorem was originally discovered by Weierstrass. So this is Weierstrass approximation theorem. The statement of the approximation theorem as originally discovered by Weierstrass is as follows. Normally, approximation theorem is the branch of mathematics which studies the process of the approximation general function by simple functions such as polynomials, finite elements, or Fourier series. So Weierstrass approximation theorem suppose f is a continuous real value function defined on the real interval of AB for every element less than zero. There exists a polynomial P such that for all x in AB we have fx minus px greater than less than all the elements or equivalent the supreme norm f minus p less than the elements. There are some version of Stone-Weierstrass theorem. These are Cartesian version, real version, native version, local compact version, C algebra version, complex version. For all those versions, there have different types of theorem. Now these two men are Hermann Muntz, a German mathematician. Now remember for the Muntz approximation theorem, and Otto Szasz, a Hungarian mathematician who worked in real analysis, in particular on Fourier series. He proved the Muntz theorem and introduced the Szasz-Maclaurin operator. So what is Muntz theorem? The Muntz theorem is a basic result of approximation theory proved by Hermann Muntz in 1940 and Otto Szasz in 1916. Roughly speaking, the theorem shows to that what extent the Weierstrass theorem in polynomial approximation can have holes dug into it by restricting certain coefficients in the polynomials to be zero. The form of the result had been conjectured by Sergei von Stein before it has proved. The theorem in a special case states that in necessary and sufficient condition for the monomials x to the power n and a elements of S subset n, no span a dense subset of the bunch space CAB of all continuous function with complex number values on closest interval AB with a greater than 0, with the uniform norm is that the summation of n elements of S 1 divided by n of the reciprocals taken over S such diverge S is the largest set for interval 0b. The constant functions are necessary, assuming therefore that 0 is in S. The condition on the other exponents is as before. More generally, one can take exponents from any strictly interesting sequence of positive real numbers and the sum result hold such so that the complex number components the same condition applied to the sequence of real parts of there are also version of LP spaces. So this is the Muntz theorem. We can see that this is the theory with 2 point. This is the and here is the proposition of this theory. This is the proof of this theory, Muntz theory. And finally there are 2 possible cases, and these are those 2 cases. So this is the Muntz theorem variant of Weierstrass theorem for polynomial or approximation theorem. So therefore, if f is the elements of H infinity and alpha 1, alpha 2 are the zeros of f in D, if m a summation of infinity n equal to 1 minus alpha n equal to plus infinity, then fz equal to 0 for all z is the elements of D. We decode that gz equal to 0, all z belongs to D. In particular, t to the power k infinity t to the power k equal to t to the power k dut equal to fk equal to gk minus 1 divided by k plus 1 equal to 0. Here k equal to 1 to 3 infinity. This is the proof. Let's prove by Weierstrass approximation theorem. It is enough to see that x contains all the function tk with k equal to 0, 1, 2, 3. Suppose that e k0 belongs to elements of n such that tk to k0 not elements of x. By Hahn-Branch theorem exists a bound linear function t c01 minus r such that t to the power k not equal to 0 and t span 1 equal to t lambda 1 t lambda 2 infinity equal to 0. Rice-Rhapson theorem, the space of Borel regular complex measure Mi is the dual space of Ci by this. Here we can see the equation. Since t varies, the hypothesis of Rice representation theorem exists a Borel complex mere U such that this equation satisfying. In addition, this is the 2 point of this theorem. So this is the complete of this proof. Thank you so much for your time. I hope you like my presentation. Thank you.